In question number 2, we're going to do very much the same thing that we did in question number 1, but we're going to focus on the geometric sequences instead. The geometric sequences are the sequences that multiply or divide. And that, again, is opposed to the arithmetic sequences that either add or subtract. So if you want to keep thinking about those two new words, arithmetic looks like the word arithmetic. It's actually spelled the same way, it's just pronounced differently. Arithmetic refers to adding, or adding negative numbers, which is subtracting. So arithmetic means adding or subtracting. Geometric means multiplying or dividing. And that's what we'll look at in question number 2, those multiplying and dividing patterns. One quick thing that you're going to notice about the equation template to fill in question number 2, letter A, is the fact that it has a slightly different structure than the one you saw in number 1. Notice, for example, that it has 2 blank spaces but no plus sign. It makes sense that the arithmetic has a plus sign, because remember, arithmetic is adding, and geometric is a multiplication pattern. So the parentheses here, which probably remind your brain of multiplying, kind of makes sense in context when you think about it. Multiplying things should look different than adding things. We use different symbols there. So that's one of the biggest differences to notice right off the bat. Another noticeable difference is the n itself. Do you see how when you're looking at this closely, this template in question number 2, it looks like the n is kind of small compared to the n that we used in number 1, which was font size a little bit larger. That's because the n in a geometric sequence is actually an exponent. It's a power. And if you look at it carefully, you can kind of see that it's not at the same level as the actual blank spaces. You see how if I extended the blank spaces here, the n would look like it's kind of floating above? That's what powers look like. So n is actually an exponent. And I'll make that as a note to myself, but I'll certainly encourage you to write it down as well. That's another major difference between arithmetic and geometric, is that in a geometric problem, we have an exponent n, and in arithmetic problems, we don't have any exponents. So, little noticeable things. But let's go back and use Desmos and our experience to help us see if we can figure out where exactly these numbers, both inside and outside the parentheses, seem to come from. I went back to my Desmos really quickly and I just found a few examples of geometric cards. So if you want to go back to your own Desmos activity so you can see these for yourself, that's great. And if you don't, you can always just follow along with the ones I've selected on the screen. All of these green cards are geometric, and you can tell because they all have a multiplying pattern. Notice in this card, for example, we're multiplying by 3. 2 times 3 is 6, times 3 is 18, times 3 is 54. Another card, this one, is also multiplying times 3. 1 times 3, 3 times 3, 9 times 3. Some of them are dividing, which is technically just multiplying by a fraction. So this one is also considered geometric because dividing by 3 or multiplying by a third connects all those terms. And this is the same exact set of terms. Dividing by 3 works there too. So we know that these are all considered geometric. Let's explore what their blue equations all appear to have in common for a moment. If I pull all of these blue equations together so I can see them, notice a few similarities. They all have a number inside the parentheses. Let's see if we can remember which goes with which so that we can compare. What must be that significance of the number inside the parentheses? Remember how we said in this pattern here, the pattern was multiplying 3 times 3 times 3 times 3 times 3? Notice that the 3 is the number inside the parentheses. This card was also multiplying times 3. That was its pattern. And notice that 3 doesn't appear to be in the parentheses, but an important similarity with the first card we looked at, that number is being raised to the power of n. The parentheses number always seems to be attached to the power of n. So even though this one doesn't have literal parentheses, it does have the power of n, which is tipping me off that we must be onto something here. Now, this pattern was dividing by 3. And you might be thinking that's a deal breaker, like, oh, dividing, that's different. But remember, dividing is just multiplying by fractions. Even if you suck at fractions, you probably still remember that fractions are just division problems. So if we think about it logically, dividing by 3 or multiplying by a third makes that 1/3 jump out to us here. Now all of a sudden that 1/3 in the parentheses makes sense. It looks like the number that we're multiplying by or dividing by is the number inside the parentheses. So let's confirm that last one. Let's see if that's true. We know that in this pattern we're dividing 3, dividing 3, dividing 3. That would be a multiplier of 1/3. 1/3 is the same as dividing 3. And sure enough, there's a 1/3 in those parentheses. So now it seems that we've made a really important observation. Now it seems that we can conclude with certainty that the number inside the parentheses, the number attached to the n, is the number that we're multiplying by. Since we called in an arithmetic sequence the name adder to describe what we're adding by, we're going to say that the thing you're multiplying by is called a multiplier. So the number inside the parentheses, or the number that is attached to the variable n, is called the multiplier. Now going back for a moment, let's make sure that we think about what this other number could be. If you're already thinking about your arithmetic experience, you're probably kind of tipped off already, like, Herbert, I know where this is going. Let's check. If you think about, for example, this one with the 324. 324 came up in the table here, in the 0 spot. Think about this equation here with the 2. 2 came up in the table here in the 0 spot. I bet that's tipping you off to think, I bet that's the initial value. And it is. The number outside the parentheses, the number at the beginning of the equation, is the initial value. This one looks like it's missing an initial value, but technically there's a 1 before that 3. So 1 times 3 could definitely be an invisible number 1 there, and sure enough, the initial value is 1. This last one is a little tricky because it doesn't have a table. But if you extended backwards, because remember 324 would be the first term, 108 would be the second term they give us. If we went backwards, the pattern would have extended backwards, and this number before 324 would have been very big, 972. That one's a little harder to see, so let's go with what we can see more concretely. That the 0 term is definitely the initial value, and we can tell that is the number in the equation, in that first spot. So I can fill in this blank then for sure. This little blank outside to the left of the parentheses, the one that's not attached to the end, is definitely the initial value. So let's summarize. Let's make sure that we're in fairly good shape. We know in letter B that when the pattern is dividing, we have a fraction multiplier. And if you're worried that you're like not good at fractions, you're thinking that's going to be an issue for you, I wouldn't worry about it too much. The fraction is generally 1 over whatever your dividing number is. So I'll just kind of write that informally, 1 over whatever you're dividing by. If you want to write that differently so that way it doesn't look quite so long or confusing, you can definitely do that, but I'm just kind of showing it there. The dividing by 3 example that we saw in the Desmos cards, so I'll just go back here to make sure I pointed out, dividing by 3 was the way we probably thought about this pattern, and the fraction is 1 over 3, 1 over whatever we were dividing by. This one was also dividing by 3, so 1 over 3. There's another example here that I'll show you quickly. This pattern was dividing by 4, and notice the multiplier is 1 over 4, so it's 1 over whatever you're dividing by. Now, in the last question on this page, question C, it says, what do you notice about the way the variable n looks? We already talked about that too, so I'll ask you to put this into your own words. The n here is an exponent when you're dealing in a geometric sequence, but when you're dealing with arithmetics, it's not an exponent. So that's the main difference between arithmetic and geometric. In a geometric, it looks like an exponent n, and in an arithmetic, it's a regular standard size n. Take some time to process all of those differences to make sure they make sense. And once you do, the next video will walk you through the next page.